Okay, here we are at the bottom of page 2 for section 4.2. So 4.2, page 2b. And you try now. Number 34, 3x minus 6y equals 15. And we're going to do use intercepts to graph this equation. So hit the pause button and come back when you've got the line and then compare it to what we have. Okay, so you should get an x-intercept of 5, 0. And again, I think I'll back up just a bit and emphasize these x and y axes here. Okay, so you should get an x-intercept of 5, 0. And then you should get a y-intercept of 0, negative 5 halves, or negative 2.5 here. So fraction or decimal, whichever works better for you. And then we connect that. So your graph should look something like this. And the arrows are important because we want to show that it continues forever. Okay, now what if you get this problem right here where it says y minus 4x equals 0. It doesn't look any different when you first look at it. It's got an x, it's got a y, it's got things going on here. So let's do the method that we're getting used to in this section, and that is to do a cute small version of the table and pick easy numbers to plug in. And we don't just pick our x's, we pick one x to be 0, then we turn around and we let y equal 0, and we see what happens there. So let's first do the x equals 0. We take y minus 4 times 0 equals 0. So I'm going to put in 0 for x. And it becomes y minus 4 times 0 is 0 equals 0, or just y equals 0. So you plug in 0, you get 0 out. Okay. Not a problem. 0, 0 is a point. We can go ahead and plot that on the graph. And again, I think I'll take the time to extend our axes here just to make it real clear on the page. Y plus and minus, x plus and minus. Okay. Now, for those of you that are kind of paying attention here, if I plugged in 0 for x and it gave me 0 for y, well, what's going to happen when I plug in 0 for y? Let's look down here. Let's see what happens. Some of you should already be able to figure this one out here. But we'll finish it out. Y minus 4x is equal to 0. Let's plug in 0 for y this time and see what happens. And we end up with 0 minus 4x is equal to 0. The 0 falls out and you're just left with negative 4x equals 0. And to get x by itself, we would divide both sides by negative 4, and you would get x is equal to 0 divided by any number is going to be 0. So you get 0 there, which shouldn't surprise you. 0, 0 should turn around and become 0, 0 again. Plug in 0 for x, you get 0 for y. You turn around and plug in 0 for y, you should get back to that original one. So what we did here is we found both intercepts, but it happens to be one of those points that goes through the origin. So what we didn't get, we got that the x-intercept is equal to the y-intercept, which is equal to 0, 0, but we didn't get 2 points. We still need 2 points to draw the line. So while this is an improvement over having to pick 5 points, plug them all in, then connect the dots to create a line, sometimes this method fails us because we end up with just one intercept. It's the same place, the origin. So now we have to pick a second number. So we pick a third number to plug in. So we go back to our x and y here, and let's pick, oh, I don't know, let's pick 1 to plug in for x. So y minus 4 times 1 is equal to 0. Now we're going to solve for y, so we're going to put 1 in there for our x. So y minus 4 is equal to 0. Add 4 to both sides, and you get y is equal to a positive 4. So we get the point 1, 4 to put on our graph here. So go over 1 and up 4. 4, we had the point 0, 0 earlier. And now we can connect that line. And again, adding the arrows so that you are visually showing anybody who happens to walk by your graph here, hey, this is a line that goes on forever. It's not just a closed set of points. Every single point on this line, as far as we could draw it, which would take forever because it does extend to infinity both directions, every single point on that works in this equation. You could pick any point on this line and its two coordinates, even if it were in between, even if it had fractions and decimals, its pair of x and y would work in this equation. Okay. So page 240 has this helpful reminder of how to use intercepts to graph a linear equation. And then I didn't emphasize this, but this is a nice little kind of check way to make sure you're on the right track. When it's all you on the exam, you got to have a way to check your work. So notice the book emphasizes at step 3, find a checkpoint, a third ordered pair solution, which is what we had to do when we just had the two intercepts. But they're recommending that you do that all the time just as a way to check your work, because if you grab a third point and it ends up kind of off, you can't draw a straight line with your 3 points, you've made an error somewhere along the way. Okay. But usually errors are few and far between when you're just plugging in 0. So I don't find this a critical piece, but I think this is a great option and a great way to help you be more confident on the exams if you have a way to check yourself. But it becomes necessary when your two intercepts are the exact same point at the origin. Okay. All right. So let's move on to page 3.